set of new AI tools and the way that they're going to be developed and where you find them. So, as part of the 7.8 series, and as I talked about at an OCLC meeting back in March, or an ALA meeting back in March, MarcEdit is introducing a set of AI tools, and these are being brought in as a plugin. After you install the application, you'll find it in the plugin manager, generate metadata. Um, Once you activate it, it'll show up here inside the application. Right now, it's just a little bit of a simple window. The tool's been designed currently to work with local LLMs running using what's called a llama. A llama is a application, that open source application that allows you to download and run models like a web server locally on your machine. Super easy to download. You can select models. There are lots of them. Uh, you're looking for ones when running on a laptop, probably that are no more between, say, 4 to 9 gigabytes in size, depending on how much RAM you have, but they allow you to run and do things locally on your device. And so I'll show you both. So um, the tool is set up to run either using local LLM models or using Gemini if you have a key, or working with Amazon Bedrock. And the reason I've chosen Bedrock is because Amazon includes a large number of LLM models. Currently, I have selected Nova Pro, but I will be folding in a number of common LLM models like Claude Sonnet, as well as a handful of others. I've been asked if I'll support OpenAI. At this point, I don't have a key, and I suppose if I get one, I can go ahead and set up a workflow with it. But that's going to just depend on when I can, find access to a key. Um, so on this screen, this is where you activate models. The tool will by default look to see if a llama is running. If it's not, then it won't find a model. It'll look for keys, and if your keys aren't set up, then it won't show them. So when you first open this tool, you'll probably not see any LLMs there because it's waiting for you to select one. MarcEdit has different outputs. Um, by default, it selects Mark's XML, but it can do tab, double accord, JSON. And then there's an option here for additional content context. So this is where you can add data to the prompt, inject data into a prompt that you're working with that will help with the LLM in terms of processing and selecting metadata. Inside the configure metadata option, this is where the prompt is set. It talks about what the data response is going to look like. It's done this way so that in the near future, I plan on changing the current way that the tool generates metadata so that it will output via templates. So the templates will be small snippets of Mark XML, and you'll be able to map um, data that's applied in the prompt, in the JSON prompt that you create, or the prompt that's created to output in the prompt, to new fields that can then be outputted into the data that's in the templates. And then that template will be used for translating data into either tab delimiter or other formats. So once and if you've made changes to the prompt and it gets messed up or you don't like it, you can just hit reset to the default prompt and it'll put it back to what the prompt was when the program was first installed. I make changes to this prompt all the time. When I make changes, the program's going to look to see if you've saved a copy of your own version of a prompt. If you have, it'll prompt you and say, there's changes. Do you want to use them? If you say yes, then it'll apply the new prompt. If you say no, then it'll just ignore it, and that'll be the last time you get asked until the next time the program is updated. All right, so I have some files here. I do have some local LLMs running. I'm using Gemma 3 and 4. They're really good. Gemma 3 is a good prompt if you have a single CPU. 4 is the more current version. I'm using the edge case LLMs within the space. So let's go ahead and take a look at how this works. So in this case, this tool's been designed to work primarily with digital content. So I'm going to go ahead and grab some digital content. So I have here an AI test. There's two images in this file. I'm going to go ahead and select it. I'm going to go ahead and create an output file. In this case, I'm just going to create a new one. And I'm going to select an LLM. So I'm going to start with using an LLM from outs that's not running locally. So in this case, we have for Gemini, we have two of them, 3, 2, 5. I'll add options, so you'll be able to select from additional Gemini models. There's a 3-point model and a couple of others. The reason I picked 2.5 is that I have a key. Those keys give you a certain number of tokens per month, and 2.5 being the previous model gives you more tokens that are available per day, per month. So roughly, if I was doing some generative metadata AI work, I would have roughly enough tokens per day to process about 2,500 items before I needed to attach my key to something that would allow me to, that would pay for additional use. Um, and then I have Amazon Nova, which uses AWS. I've attached this to an AWS account, so I pay per number of tokens. So I'm going to use this one. That way you can see how it works on a external service. So I hit process. Once my data is selected, you'll see that it tells me file 1 and 2 are being processed. These are not the names of the files. You can see it's already done. The reason you see those file names is that one of the things that the tool does is it supports a wide range of image formats and PDF. When it processes image data, most LLMs don't work directly against the image data, or they provide significant restrictions to the size of the data that can be sent. So what MarcEdit does is it reviews the size of the file. It then restructures the file so that it's in a scaled format with resolution and ratios being respected. And then it translates it to PNG because that's one of the most common formats that most LLMs support. And so that way it uses that as the communication format. So let me go ahead and pull up our AI folder real quick. So I have my AI test. And this was the output. So it output two files. So here's the first one. This is the Mark XML file generated, and I'll show you the images. It says a group of individuals sitting at a table, group of individuals, and then it gives you the information there. The particular file that was being processed is a file from, I think it was this one. Yeah, this is a file from Kristen Cinema's uh, government, her office's output. It's of a breakfast that took place in Arizona with Senator McCain and a few other people in attendance. The LLM uh, didn't recognize the individuals in the space. If I used an LLM with a larger number of tokens or defined slightly, possibly it might have. In this case, it just recognized them as people and stuff that was going on. Let's go ahead and look at the other one. In the second one, it gives you the name of authors, a title, publishing information, and a description. This is an image of oops, a book cover. So the tool read and translate. Um, if I wanted it to not translate and keep the source language, I could add that to the prompt and ask it to do it. And in fact, some LLMs like Gemini likely would not translate the data and would just take it as is. Certain ones do certain things by default, and so you just have to tell it what you're doing. But you could see this is an example of where it actually read the the data here and it pulled that information out. In fact, if I was probably doing this more, I might actually consider keeping a field for translated data so that I can attach paired fields to the data if I didn't want it to be all in a specific language. All right, so that's an example of running externally. So I'm going to go ahead and run those same files, but I'm going to run them through the local LLM just so you can kind of see how much slower it is. The reason why the local LLM's been provided is specifically because there are times where you're going to work with data probably that you don't want moving back and forth across different to a remote source. And something like Gemma could provide you the opportunity to process the data. It just takes more time, which means it's probably one of those things where you would point to a set of files and you would let it run, and then you would come back to it later. So I'm just going to let it finish the first one. It's going to probably take somewhere between 20 um, and 35 seconds. So the application here is running. My computer has an AI chip. It has an i9, and it has somewhere in the neighborhood of around 120 gigabytes of RAM. So it can pull all of this data into memory and process from there. So the challenge with running everything locally is that Olama currently isn't created to support an NPU, which is an AI, dedicated AI processing core used in a lot of chips. Um, that's supposed to be coming. When it does, that'll probably speed things up. It's primarily a CPU-based device, so you can offset some of the load to the GPU. I can provide some documentation online and how that happens so that it runs faster. Right now, this is running basically out of the box Olama, so it's forcing the data through the CPU, and it's trying to process the information. And what's happening is it's taking the data to the image, and then it's using the prompt that's provided and asking the LLM to look at the image and process it. I found that for local processing, sometimes text-based processing happens faster, but that depends on the size of the text-based processing. The more tokens you add into um, the local process, the longer it takes. But you can see that it finished the first file and now it started the second. So what happens is if you're wanting to run on this local, you probably could process something like this at the speed that it's running. I could probably process a couple thousand items during a day. What I would do is I would get it ready to what I love, to what I need, and I would just set it to run on a device and then forget about it. So while this is finishing, I'm just going to go ahead and grab the individual file so we can compare it to the data that came out of the other one. So in this case, we pull this data up. This was the file that was in the um, uh, tool that it recognized. You will see that it identified some people. I'm not 100% sure those are all right. I have to look. Meeting in attendance, group of individuals sitting around breakfast. So roughly about the same information that the Amazon item found, um, with some additional data that it attempted to locate, which we'll have to confirm. And then we'll see if the other one is finished so we can look at the other file. And if you look at the other file, you'll see that in this case, again, it's separated into two items. It has translated the data and output it for use. So this is a tool that's being created right now within MarcEdit. It'll be optimized quite periodically. Um, you can see a couple of placeholders here inside the program, one specifically in the additional context where there's a placeholder for selecting files. The idea behind this is that you'll be able to pull files into the application as a small local knowledge base that'll be used as part of the metadata generation process. They won't specifically um, be used for the output. They'll be used to provide additional context for the output. So for example, say you're processing a collection that came from a specific special collections, you could upload the EAD file or point to a website where information about that collection lives, and that data will be used as part of the process for generating metadata. So that's the tool right now. Like I said, I believe at this point it's primarily good for digital collections. I've been making use of it periodically for small collections that are primarily digital, primarily image and PDF based, for creating what I would consider to be discovery data. Is it good enough to replace what a cataloger does? No. And I'm not sure that's the point in this case. The goal of tools like this should be to allow the institution to identify which collections you're digitizing that require full cataloging and a professional cataloger, because they're materials that are important enough for the institution to dedicate the resources to the discovery and the description of that content, and which are those collections that sit on the tail end that end up being stored on local file systems and just up in the air that don't get provided access to. Every institution has an archival backlog, and every institution has data that's never going to get made available to the public. And tools like this are designed specifically to help bridge that gap and start allowing you to create metadata that can be used to specifically improve discovery and make accessible, usually for the first time, materials like this. And the nice part is, because these tools are automatically generated, you can create workflows that allow you to update that metadata periodically without taking staff time, to improve access as the LLMs and the tools get better. That's how the tool works. If you have questions, let me know.